All right, we looked at ionic bonding, so now we're going to go ahead and look at covalent bonding, another one of the main bonding mechanisms that we see in materials. So, unlike ionic bonding, covalent bonding is often found between non-metallic elements. So, some common examples of this that we would know of are going to be H2O2, H2O, CH4, molecules such as this. But it can also be found in pure elemental solids. So some of those would be diamond, which is all carbon, silicon, and germanium, which are found as solids in their pure elemental form. And this also we can generally see is going to be elements that are found towards the right-hand side of the periodic table. So covalent bonding is the sharing of electrons. So we're going to go ahead and look at H2O. So if we have an oxygen and two hydrogens, to really see this, we're going to have to look at their H valence electrons. So we know that hydrogen just has one, and we also know that their shell is missing one. And then oxygen has 6, and oxygen's shell is missing 2, right? So now when it's drawn like this, we can kind of see what's going to happen. This guy is going to share, this guy is going to share, and then we're going to get an H2O atom, which is going to look schematically something like this, right? Oops. With shared electrons, which then fill the valence shells for both oxygen and hydrogen. So hydrogen has 2, oxygen has 8, they're all happy. We can look at that again with CH4. So I'm going to go ahead and erase this so we can see it a little bit better. CH4, if we have our carbon, right, we'll just go ahead and draw all the shells of carbon just so we can see. And then our hydrogens on the side. So what do our electrons look like? We've got the first shell and then the second shell here. These are the electrons that are natural to carbon, and then our hydrogens over here each have 1. And we can see how this is going to make everyone happy by just adding, there we go. And so our carbon is bonded to 4 hydrogens and sharing 4 hydrogen electrons with those 4 independent atoms. So this is kind of neat that it can make so many different bonds. So how many bonds can we make with each element? So this depends on the valence electrons. So if we have an element with n valent electrons, we'll say, this can bond with 8 minus n other atoms. So if we look at these two examples we have here, for oxygen, n is equal to 6. And so the number that it can bond with is going to be 8 minus 6 is 2. And sure enough, we've got 2 hydrogens. For carbon, n is equal to 4. 8 minus 4 is 4. And sure enough, 4 hydrogens. So what are the bond mechanics of covalent bonds? This varies greatly. So covalent bonds can be very, very strong. If we think of diamond, and diamond is a structure where it's 3D. The 3D lattice is one carbon is bonded between 4 different carbons, and they're kind of interconnected. And for diamond, the melting temperature is greater than 3,500 degrees Celsius. This is super strong. Or it can be weak. In, for example, bismuth, this has a melting temperature of just 270 degrees, which is a lot weaker. These energies can be found in tables. And another interesting thing is that polymers are often covalently bonded. So if we remember polymers, they're just chains of molecules, right? And these molecules can then be bonded together, often covalently, at points where they cross, points where they're near each other, etc. And so that's kind of what covalent bonds are often known for, is their role in polymer bonding and then non-metallic bonding as well. We can also have part ionic and part covalent bonding. And this is something that's actually very common. It's very rare that something is completely pure covalently bonded and completely pure ionically bonded. So if you're interested in that, you can watch my video on the percent ionic character. That'll tell you how to solve for that and different ways that that occurs. As always, let me know if you have any questions.